Good morning, welcome to Builders Academics Online Tutorial. Thanks for watching our YouTube channel. Please, if you have not yet subscribed to this YouTube channel, do well to press the subscription button and the notification bell in order to watch all of our videos online. Help us to make this channel known in order to be able to serve more people better. Please do well to like this video, press the notification bell and share with your friends. Thank you and God bless you. Today we'll be considering practical geography, known as map reading. What do you mean by map? Map is the representation of Earth's surface on paper. The process by which you represent a particular area on paper is what we call map. And map reading is very, very essential in geography. Map reading can be defined as the ability to recognize conventional signs on a map and to interpret what those conventional signs mean or what they stand for. So, and this is what we are about to do here as we consider the why question, both in objective and in theory, now to help you to understand what map reading is all about as far as why and NECO or NSS's question is concerned. Now, here is the question in 2019 why school candidate objective. The first question says, study the map of Niti district. We have to study the map of Niti district on this page and use it to answer the question 1 to 10. As we can see, this is the Niti district map, and we have to use it to solve the questions that follow. What is the contour interval of the map? What is the contour interval of the map? Contour interval of the map. That's what the question was asking us to the contour interval of the map. Now we are talking about contour interval. What do you mean by contour first? Contour is is a line used to denote or used to represent the relief of a particular area. Now we use contour line. As you can see, these are contour lines. They're like a curved line or a circular line used to represent the relief of a particular area. How do you mean by relief? Relief is the characteristics or position of a lowland or island on a particular map. So what am I trying to say is that contour is used to represent the highland or the lowland of a particular area, how high it is or how low the area is. Contour line will give you information about that. And contour line starts at sea level. Now the graduated mark for contour line start at sea level. At sea level, which means the minimum contour line is at sea level. So, and as it approaches the higher ground or the higher land, it increases with equal interval. And that's what they are asking us here. They say, what is the contour interval on this map? Each contour is separated from one another by equal interval. It can be 50, it can be 100, but they must be of equal interval. So what is equal? What is contour interval? Contour interval is the difference between the contour, one contour, and the next contour line. So now, for example, now if I have the contour from sea level to 100, the next one will be next one 200, next one 300. No, sea level is this list that we can have here. 100, 200, 300, and so on and so forth. 400. You can see the equal interval here is 100, 100, 100. So the equal interval here is 100. So also on this map, when you look at it very well, you can see this. You can see 300 here. As you can see the sign for an area liable to flooding. Now, why is this place liable to flooding? There's tendencies that this place can get flooded because it's very, very it's very close to the sea level. In fact, it is 300. So it is the least contour line. So this is taken as the sea level, and it's very, very it has high tendency to be subjected to flood. So that's why they said that area liable to what? To flood. That is what the mark means. So now, but we are not going to that. What we are asked to what? To answer in this first question is to tell us the contour interval, which is what? You can see the difference between what? These contour lines are what? 100, 300, 400, 500, 600, 900, 1000. So that is the difference. That's the difference between one contour line and the other. So the answer here is what? The contour interval here is 100. So 100 meter, because they were told that the contour in meters. So it means that this contour is in meters. It's measured in meters. So it has been given for us. So the contour interval is just 400 minus what? 300 is equal to what? 100. So that's that. About what? About that. Now let's do it to answer the number 2 question, which is, what is the scale of the map in statement 4? What is the scale of the map in statement 4? Number 2 say, what is the scale of the map in statement 4? Scale of the map in statement 4. In statement 4. Now, the first thing is to ask ourselves, which scale are we given in the first place? Now, when we check this very well, this is 1:50,000. So this is a representative what? Scale. This is a representative scale. You are given what? 1:50,000. This is a representative what? Fraction. Now, first of all, before I even answer this question, there are 3 types of what? Scale that we use in map what? Map reading. 3 types of scale. There are 3 types of what? Of scale that we use in map reading. There are 3 types of scale used in map reading. This is a map reading. Number 1 is what? The statement what? The statement scale. The statement scale. The statement scale is a scale which is given in form of statements and figure. For instance, now, e.g., 2 centimeter represent, that is 2 centimeter on the map. Every 2 centimeter that you measure on the map represents what? 1 kilometer. So this is a statement what? Scale. By the way, scale shows the relationship between the distance on the map and the distance on the ground. So what distance in the map represents a particular distance on the ground? So is this one saying that for every 2 centimeter distance you measure on the map, it represents 1 kilometer on the ground. So this is a statement what? Scale. Now the next one is the linear scale. The linear scale. This linear scale makes use of a drawn line. A drawn line that is drawn, a line that is drawn in a particular unit. So it is makes use of a drawn line to show the relationship of distance between the distance of 2 points on a map and distance on the ground. For instance, now in a linear scale we have 2 divisions. We have one to be what? To be primary division, which is the main unit that we use, primary divisions, and we have the secondary what? The secondary division. The secondary what? Secondary division. So we have this is 0, 1, 2, 3, then what? 4. This is in kilometer. The first division, the primary division might be in kilometer, and here on the secondary division, it is used to measure the remaining smaller part of the distance. Maybe this one might be in what? It can be in meter. So it's usually a meter. Now this is can be 1 or square, or 500 meter. It can be 500 meter, and so on and so forth. It can be in form of 1/2, 1/4, and so on and so forth. Just as an example, but along this side we have what? Meter. So you can see this primary scale, this secondary what? this is secondary scale. So this is a linear scale. A linear scale makes use of a what? If you look at this very well here, we have a linear scale here. You can see on this right hand side we have 1000, 0, 1, 2, and here we have kilometers, here we have meters. So this is a linear scale. Linear scale. In fact, we still have what in this big graph, in this big map, we still have both. We have linear scale. We have what? We have representative what? Representative scale here. And we still have what? We have what? Linear scale, we have a representative fraction, and we still have statement scale on one map. So we are now told now, the last one before we go into the question that we are solving is that we still have a representative fraction, which is a third type of scale, a representative fraction. The third type of scale that we have is a representative what? Fraction RF. Don't forget, number one is what? Statement scale. Number two is linear scale. Number three is representative fraction. Now this make use of what? Ratio or fraction. That is, in this type of scale, the distance on the map and the distance on the ground is expressed in form of what? Ratio. In ratio to each other. That is the distance of the what? On the map ratio the distance on the what? On the ground. So for instance now, in this question that we are given what? This question 1:50,000. That is, for every 1 centimeter that is measured on this map, it represents 50,000 centimeter on the ground. So that's what we call what? That's what we call representative fraction. So this is a representative fraction. So the first three type of what scale that we use on map is number one, statement scale in form of words, in terms of what? Statements and figure. Number two is the linear scale, which we use what? A drawn line to scale. So which can have two division, primary division and secondary division. And the third one is representative scale. Now representative scale, which is representative fraction RF. Now the question is, what is the scale of the map in statement what? In statement form. Now the question, coming back to the question now, which says what is the what? What is the scale of the map? The scale of the map in what? In statement form. Now when you go to the scale of the map of Nitti district, now the scale of map for Nitti district is given as 1:50,000. So which this is RF. This is RF for scale. Now we are asked to take it to statement scale. So how do I take this statement scale? We know that what? Once this means what? This is distance on the what? On the map, which is usually 1 centimeter here, and this one is what? Distance on the what? Distance on the what? On the ground what? On the ground. So this is 50,000. It's 50,000 centimeter. So we have to take this centimeter to kilometer by dividing by 1,000. So 1,000 by divided by 100,000, because for every 1 kilometer we have 100,000 centimeters. So 100,000 centimeters make 1 kilometer. Please note that 100,000 centimeters make 1 kilometer. So we divide 50,000 centimeters with what? 9,000. So we have what? This one cancels this one. We have what? 50 here 1, 50 here 2. So 1 centimeter here represents what? Or 1 centimeter ratio what? Ratio half kilometer. In other words, if we want to put it in a statement scale, it means that 1 centimeter on the map represents half kilometer on the ground. So that's just the statement scale. If I have to express this in a statement scale, that I will express 1 centimeter on the map represents half kilometer on the ground. So that's that about number question. Now let's do number 3 question. It says that question 3 says the approximate length of R dot of 1 R dot of fund. R dot what? That is the region of fund. The region of fund. What is the what? The approximate length of what? R river of fund. River of fund. River of fund. The approximate what? River of fund. You can see this river. This is a river. It has a bridge. You can see this is a bridge. How do I know it is river? The river of fund is what? Is river of fund is starts from this word. This is a high word. This is a ridge. This map structure is a ridge. So it's coming from what? A ridge here. No, this is a what? The top of what? It's like a hill. You have a saddle here. So, but let's continue. It's coming from the river is coming from here to here. So now, so they were asked to calculate the what? The length, the approximately what? The approximate length of what? Of Fond River. Now, how do you calculate the approximate length of what? Of Fond River. Now, there are two ways to calculate what? Distance on your map. Distance on the map. Now, there are two types of distance. We have what? We have straight distance. When you have straight distance, you make use of what? Meter rule. Whenever the distance you are having or your hands measure on what? On a map is straight, is uniform. You are going to use what? You are going to use a uniform ruler. A ruler, which is what? You can use a long ruler, which is, it can be what? It can be 15 centimeter ruler, it can be 30 centimeter ruler. It depends on the length of something, how long that thing is. So whenever you have a straight distance, you can use what? Long ruler to measure the length. But in the case you are given what? You are given, in the case that you are given a curved line or a curved distance along a curved line. Distance along the curved line. So I call it curved distance. You can use three measuring materials for this. You can use three materials for measure this. Number one is what? The most acceptable way is to use thread. A piece of thread. You can use thread. Is one of the most accurate tools that we use for measuring curve on map. So we have thread. We can use divider. Divider also is acceptable if you are good in it. Using it, so divider, and we can also use the edge of a paper. Edge of a paper. You can use what? You can use a thread. You can use a thread. I'm using this. You can use a thread. You can use also a divider to measure the distance or the curved distance on the map. And also you can use the edge of a paper. Something like this. You can use the edge of a paper to measure the distance. Now let's use the thread. I said the thread is the most convenient way of what? It's convenient method of measuring distance on a map. So it is advisable to use thread. So you place this edge of a thread here. You place it along the curve of the river. You hold it like this. Now, as you are holding it, you use your hand to hold it like this. Then you continue along this line. So at least about something that now. You put your hand again here, gently. So we have, so you get here, you put your hand here again. Okay, you do it bit by bit, one after the other, so that you can have an accurate result. Okay, so we stopped here. So this is the point. This is the point. Let me just mark the point now. want to mark the point. You can do that with your pencil. You can do that with your pencil. If you have to make sure that you mark it very clearly. You mark it very clearly. So okay. So now, after marking it like that, after marking the point on your what, you can see I've marked it here, which is the red point here. So now I will now measure this on a meter rule. I will take my meter rule and I will measure it on the meter rule. And if I measure it on the meter rule, what will I have? Okay, this is my meter rule now. To the what? To the marked red point. To the marked red point here, I am having an approximate. Okay, let me do that again so that you can see. From 0, using centimeter now, because I'm using 1 centimeter to what? To half kilometer. That's my statement scale. Now, I'll use it from the 0 point now. I'll measure my what? So my red point stop here exactly at what? Check it very well. This is 15. This is 15 what? This is 15 centimeter. This is exactly what? 15. That's approximately what? 15 centimeter. So it means that the distance of the what? The river of one. Length of what? River of one. River of one length on the what? On the map is equal to 15 centimeter, approximately 15 centimeter. So the distance of the length of river of on what? On the map is what? 15 centimeter. Using what? Using thread. Now, and scale says that 1 centimeter represents what? Half what? Half kilometer. If I'm using statement scale. I'm using statement scale. This 1 centimeter is what? Equal to what? 1 kilometer. So what about 15 centimeter? So 15 centimeter will therefore be what? 15 times you cross multiply. You use this one to multiply this and divide it by 1. So 15 times 1 over 2 all over divided 15 times 1 half all over what? 1. So if you carry the centimeter along, 15 centimeter, this is half kilometer, this is centimeter. Definitely the centimeter will cancel centimeter. So 15 times half will give you what? 7.5 kilometer. 7.5 kilometer. So that's that about what? About the distance of this what? The length of the river of one. Using the what? Using thread. So we have used thread to measure the first thing is to use thread to measure the length of the river. Then you will now convert the measurement from centimeter to what? Kilometer. To kilometer using your what? Using your scale. And you can also use the scale directly using what? 50 what? 1 ratio 50 what? 1,000. You are still going to arrive at the same answer. What you just need to do is just multiply what you get now, which is what? 15 times what? Just using, I'm using the scale directly now instead of me using statement scale. You just say, since we get 15 centimeter to be what? River of fun is what? 50 centimeter. So 15 multiplied by the 50,000 you will get here. 50,000 over scale over 100 what? 100,000. So this one cancels out 50 here 1, 50 here 2. So it's still the same as what? 7.5 kilometer. Whichever this okay, you are still going to arrive at the same. So the length of our rivers, the length of our river is what? Is 15 centimeters. So let's go to the what? Next question. Question number 4 here says that. Question number 4 says that which of the following settlement is nodal what? Settlement. Which of the following is nodal settlement? That is the next word. The next question says which of the following settlement is nodal. Now, which of the following settlement is what? Is nodal. Now, we are to what? Choose among the settlement that we have here, which of the one is nodal what? Settlement. So number 4, which of the settlement is nodal? Which of the settlement is nodal? Now we have settlements are being represented. Look at the settlement. The representation, what we use to represent settlement is box on the map. You can see they give us the word, the convenience sign below the map. So the settlement is represented by the what? By the box. So what you are going to do now is look for where this box are now on the what? On the map. So now look at this. We have for the Proga what? Settlement. The Proga settlement here lies along a road. Now you can see here, this line, this 2 line here, this line that follows is a road, and this settlement here lies along the road. This settlement here line, we call this type of settlement linear settlement. So Proga here is linear settlement. Proga here is linear what? Linear settlement. So it is not Proga settlement. It's not Proga that is nodal. Now, since Proga is linear settlement, why is it linear settlement? It is what? The settlement are located along the road, linearly along the road. So whenever you have settlement, buildings are being built linearly along the road. We call it linear what? Settlement. So no, Proga is never a nodal what? Settlement. Now let's check another settlement that we have here. We also have settlements here, which is what? We have settlements here, which is also linear. It's also linear. Same thing as what? Same thing as well. This also is also linear. The breeze settlements here is also linear. Breeze is also linear. Breeze is also what? Linear. Breeze and what? Proga and breeze are what? Linear. Now, but when we look at what? Niti settlements here. Niti here. We can see that Niti here has a built settlement. They call it this junction. This junction that was what? That is here. Because many roads meet here. We call the meeting what? We call it what? The meeting point of road. There is a meeting point of road here. There is a road coming from the what? The north what? The north east here. There is one coming from eastward. There is another one coming from the northwest. Northwest. No, this is northeast. One coming from northeast. One coming from northwest. One coming from the westward, and one coming from the southward. Southeast. So we have a meeting point here. This is a meeting point, and we see there's a built upward settlement around what? Around this meeting point. So when the settlement is around a meeting point of road, a meeting station, we call that settlement nodal what? Nodal settlement. Nodal settlement. When the buildings are located around the meeting point of what? Of roads. A station, we can call it station. Whenever settlements or buildings are being made around what? Around a station where roads meet, around junction where roads meet, where roads meet together, we call that nodal settlement. You can see big settlement here. So, and that settlement is called what? The settlement is called Niti. So Niti is the correct answer. So Niti has a nodal what? Settlement. While Proga Breeze has what? Linear settlement. Linear what? Settlement. So now let's move to the next question. We say question number what? 5. The highest elevation in the mapped area is approximately what? Dash. Look at this. The highest what? The highest point on the map is approximately what? It's approximately, you can see that the contour line that we have here is 100. Now this one will be 110. This one will be what? 200. So this is now 1,000. 1 what? when you get to this contour line here, you have what 1,100, 1,200. So the range is for approximately between 1,100 and 1,200 kilometers. So the range is here. The highest you can have here. Number 5. Let me just write it. The highest what? The highest elevation is equal to what? 1,200 meters. Because the interval between the contour lines are 100, and the highest you can see here that is visible here is 100. Now 100 plus another contour line here that forms something like saddle here or chord is what 100 plus 1,000 is 1,100 and 1,200 meters. So that's why it is the highest elevation here. What is the relief feature X? The relief feature X is null. The relief feature X is like an isolated what? Relief. Whenever you have an isolated relief like this, we can call it something called isolated hill. Now it is called null. So the figure feature S is what? Null. It can look like this, something that look like this in the map. We call it null. No. Okay. Is null. So number 7. If the map of Niti district is reduced to half, and this is a reduction. If map of Niti, let me claim this as number 7. If map of Niti is reduced to half, so this is taking us to reduction, although we are still going to do it very soon. But now, number 7 says, if the map of Niti district is to be reduced to half, what would be the new scale? Now, when Niti is reduced by half, when Niti district is reduced by half. Now, what will be the new scale? What is the new scale? The new scale is what? The new scale is, now look at this. Is when the Niti district is reduced by half. What the new scale will be? What is? Look at this. What is the former scale? The old scale multiplied by what? The number you are reducing, or you are using to reduce it or enlarge it. So the old scale by the what? By the factor that you are using to reduce it or what? Or enlarging it. So this is now the old scale multiplied by what? Half. So the old scale multiplied by half, which is what? 1 over 50,000. Because 1 ratio 50,000 is same as 1 over 50,000 times 1 over what? 2. So 1 times 1 will give you 1. 50,000 times 2 will give you what? 100,000. So we have the new scale now for the reduction is what? 1 ratio 100 what? 1,000. So that's the new scale. If it is to be reduced, that will be what? 1 ratio 100,000. So number, the new scale in RF, yes, that's what we get in RF. This is, don't forget that this is RF, representative fraction. Question number 8 says the relief features on the west of Niti, which is extended to the northwestern corner of the map, is dash. Now the feature or the relief feature on the west of Niti. Now when you look at this is Niti. This is Niti on the west of Niti. When you draw 4 cardinal points on this, the Niti is, you draw 4 cardinal points on this using pencil or any of your drawing materials. So when you draw 4 cardinal points here, let me just draw 4 cardinal points here. Also has to know the description of what they are saying. Assuming this is your 4 cardinal points now. So now he said the relief feature which extend to the relief feature on the west. The relief feature on the west around this place. The relief feature on the west which extend to the northwest. So this they are talking about what? The relief that start from here to this place, which extend to what? Northwest. This is what? This is north, this is west, this is east, this is what? South. So it starts from what? The relief feature at west and extend to north what? Northwestern corner of the map is what? Definitely look at this. We have, you can see something that extend is this. This is something that extend the whole thing here. So it looks like something like this. Something like this. So this is very important. It's a very important questions and relief. Something like this. So and they put 100, 1000 is 900. So this is a reach. Whenever you have something like this, you have a reach as 2 sections. We call it what? It's a reach. And the around here, the space here is called Sadu or coal pass. Coal, Sadu, we have reach, but this is particularly called what? Reach. So the answer here is what? Is reach. That's question number 8. Question number 8. And the last 9 questions says, in which setting is mining practiced? In which settlement is mining practiced? In which settlement is mining what? Practice. In fact, we still have one settlement here. In which settlement is mining practice? Look at this. The symbol for what mining here is. The symbol for mining here is, look at it, it's something like this is symbol for mining. Symbol for mining workings. You can see mining workings. So you go to where we can see mining workings and we can see it around what? We can see it in coral settlement. So coral settlement major occupation is what? Is mining. So major occupation in what? In what? Coral will be mining because of the coral because coral has mineral workings. So you can see mineral working sign at coral. So the settings or the settlement that will be involved in mining is what? Coral. That is number what? 9. Coral. Due to the fact that they have this what? They have the symbol of what? The conventional sign for, they have the conventional sign for mining. So if I see this thing like this, it's for mining. As far as this what? As far as this map is concerned, so mining workings. So coral is the answer. Coral settlements are engaged themselves in what? In mining, because they might be why is it that they are into mining? They might be because of the availability of what? Resources that is there. Maybe the place contain some important mineral resources that they can extract and mine out. So that's that they contain down those precious stones. Now, where can conflict be resolved in the district? That's very simple. Where can conflict be resolved? We resolve conflict in court or judiciary or justice. So you go to the map conventional sign, see what they used to represent court. Court is represented by city. So and city is located at Niti. So we can settle dispute or civil conflict at what? Niti security settlement. So that's that about the objective in 2019. So we proceed to what? In solving what? In how to reduce map, how to carry out map reduction and map what? Enlargement in what? In the next what? Video tutorial. Please remember to what? To subscribe to this YouTube channel in order to see all of our educative what? Videos online. Thank you and God bless you. See you next time.